Hosting provided by Host Tornado. They offer website hosting packages, dedicated servers, and VPS solutions. Host.t.net. Episode 18, go. Take it away, Patrick.
So I had my parents visiting, and we went to, being in the Bay Area, we went to try to do some of the touristy attractions. And we went to the infamous Alcatraz, which sits in San Francisco Bay, and you can kind of see it from my. It's this ominous old building, kind of like a lot of rundown skeletons of buildings that used to be there. No, not actual skeletons.
Did you take the picture from behind the bars or whatever?
No, I don't know. Actually, I didn't.
Oh, okay.
But it was kind of interesting, so try to keep this semi-relative, or at least maybe interesting to people. So you see like movies and stuff growing up, at least here in the States, about Alcatraz, this prison for hardcore mobsters in like the 30s, and I guess it was around that time, yeah, like the 30s. And even before then, there was like a military base there or whatever. But this is where they sent all the really bad people. And there's several famous escape attempts, and various famous prisoners that were held there. And then eventually the prison kind of closed because it was like really horrible, and also people in San Francisco were kind of like realized it was maybe a bad idea to take all the worst criminals from the country and stick them just a few miles offshore from like a really big city. Yeah. Although like that bay is really dangerous and filled with all sorts of ways to die, you know, it's still maybe a bad idea.
Did you know during the summer they have a duathlon, where they swim from Alcatraz to San Francisco and then run a marathon?
Yeah, I did see that. And the tour guide was quick to point out that those people do it in a wetsuit.
Actually, they have some people who do it without a wetsuit. I happen to work next to somebody who's going to do it without a wetsuit.
That's crazy.
And I just thought people died doing that. Like, I didn't think that it was safe.
Yeah, I mean, I guess it's different if you're like trying to do it in cover of darkness and disoriented and not coordinated, right? Like, this can be really bad. Versus like middle of the day, you know what you're doing. It's But okay, so anyway, so we go to the prison, which is cool. You know, if you're around and you haven't done it, you should do it. But I thought it was interesting because having seen it all this time, I really thought there was like all these different buildings and like rows and rows and rows of jail cells, and it was this massive thing. And it's really not.
Yep.
I mean, a lot of prisoners were held there, but it was a pretty small area where they were held.
I think it was in the hundreds, right?
I don't remember the exact number, but yeah, just not a lot. And it really fits. There's 3 levels, so it's really high. But they're open air, like it's just the cells are stacked in 3 levels. It's not like 3 floors, and you can see from top to bottom.
Yep.
But just to see how small it was, and so they've done something really creative. I guess it's like social engineering, let's call it.
Yeah,
so you get there, and then you take this boat ride over, which is cool because you're going in San Francisco Bay on this boat.
Yep.
And then you get there, and then they give you a little speech for like 10-15 minutes about all the stuff you're gonna do, and then they direct you to walk up this long hill to where the prison is. And then they give everybody headphones and this little device which gives you an audio tour.
Yep, complimentary.
Yeah, included. Well, you pay for...
That's true.
You have to pay for the ticket to get there, right? So,
right.
So, but then they give you this thing, and at first,
but the point is that everyone has one because they're free at that point. Once
once you're there, if you can get there, you get these for free.
Yep.
And so then you're touring around. So I noticed a couple things. One is that at one point I took my headphones off, and was just, I don't remember, taking pictures or something, and I had paused it. And you look around, and you just see, hundreds of people, like, wandering this jail like zombies.
Yeah, because they're all going in the same direction.
The same path.
But
overlapping each other.
Yeah.
And, like, not paying attention to people around them and bumping into each other and just...
Yep.
Like, completely mindless. It was really creepy and weird.
Awesome.
And, like, I don't know, it was very, very strange. And you could tell, like, what part people were on and, like, what they were doing. And so that was kind of creepy. But the second thing is, the social engineering part is getting at is that because it's so small, you would be very disappointed having paid, I don't know, it was an extraordinary amount, like $30, $28 or something to take this boat ride there.
Mm-hmm.
But to go and, like, you would look around and you'd be done in, like, an hour.
Yep.
And leave. And like you'd be like, oh, that's kind of like disappointing. But instead they give you this audio tour, which most places charge for you to take the audio tour, and they even have like guided tours, and so it makes you take a lot longer, and they take you on an inefficient path, and they kind of have you looping over yourself and revisiting the same places, but with kind of different story or different view, or looking at something on the wall a slightly different way. And it really makes you feel like you got your money's worth. And I felt kind of bad having pointed out to my family after this tour, like, oh, wow, that was kind of like not that good. Like, the story was good, like this audio was a good thing, but like it was really not that interesting or big if you really think about it.
It's sort of like the Matrix, and you're outside of the Matrix because you didn't have your headphones on, and everyone else is sort of like just really entertained by something which is really actually in the grand scheme of things like very tiny and like completely controlled by this like audio program. And so you're outside of it and you're like realizing these people are walking between like 4 or 5 rooms, but like to them they're just spending hours in this massive maze.
It was kind of so take it. It's worth going. Now we've polluted it, I guess. Now like you're gonna feel bad doing it, but
yeah. Well, I mean, I think it's okay. I
do
think,
it once. You do it once.
I would, if you had to pick between Alcatraz and Golden Gate Park, you should pick Golden Gate Park and like the west side and like see the bridge and stuff like that, or like go on the bridge.
Yeah, I mean, it was worth doing. I don't mean to talk down about it, but it was just this like aspect of this audio tape thing was just very intriguing to me that people are so easy to tune out everything around them.
Yeah, definitely.
So interesting. Now I'm going to be more attentive when I go to touristy places to see how they're manipulating. So it's obvious like Disney is very into this, right?
Yeah, they're pros.
Like controlling everything, like how you experience this Disney magic and what they do to do that. And
yep.
Yeah. So. All right, on to tech news articles.
All right.
So
speaking of being in jail, how do you come from that?
I don't know. A group of researchers used a interesting technique of, I guess what you call it, nanofabrication to reach the ultimate resolution of color printing. So I read this story a couple times before I figured out what was going on. But what they did was essentially were able to manufacture these metal dots spaced very, very close together. But all the dots are the same color. They don't have pigment to them. They're very, very tiny. And they're all just metallic. But based on their spacing, they're spaced about half the wavelength of light apart. And by altering very slightly the distance between the dots, they're able to generate color based on what waves can get through between the dots, like the posts, and which ones can't. And what they're saying is basically that by doing this and making this color picture, which is fairly tiny right now, it's like only like 5 micrometers by 5 micrometers, which I guess humans can only see down to about 10. But making it this small, you cannot make a color picture that is of more resolution, because if you put the dots closer together, they'll just blur together and won't have like the color aspect of it.
Because your eye isn't sharp enough?
Because of the actual physical properties of light. So light has a wavelength, right? So if you make something 2 dots closer together than that wavelength, the waves can't resolve them. It can't tell the 2 things apart. It looks like one thing. So it's like, the classic story of, I guess you hear this in physics, of if you try to figure out what object is in this room by shooting, first like beach balls at it and then like baseballs at it and then like tiny BBs at it, and what gets through and what doesn't depends on the size. So this is like trying to see, it would be like at the point of where they reach, you'd be trying to see what like a can of soda with a beach ball, like just too big.
I see
like
what
you can't tell that it's there. Maybe that's a bad analogy. Anyways,
no, I see what you're saying. Yeah, I got you.
Yeah, so it's 100,000 dots per inch. Which doesn't seem that high, because like printers do 10,000 DPI. It's only 10 times more resolution than that.
Oh yeah, you're right.
So it's not incredibly high, but
it's the maximum.
Yeah, it's not possible
ever
to do
see.
more.
That's
so these
insane.
people, like, it's cool because these people got there first and they win. Like nobody can.
Yeah, there's no
more race. Like they finished.
So it's so funny you mentioned this, because I just saw a TED Talk today on a trillion FPS camera. So a camera that could record a trillion FPS, and it can record so many frames per second that they actually like fired like a small beam of light, and you could actually see like the beam of light like enter this piece of glass and like fragment through the glass.
Whoa!
So you could actually like slowly, like it was like a slow motion like video of light.
Whoa!
Yeah.
Oh, I have to check that video.
We'll post both links. But yeah, it's amazing. Like, what are the chances that 2 like huge milestones in terms of like dots per inch in terms of pictures or frames per second were both reported in the same day?
So close, yeah.
That's pretty awesome.
That's kind of cool. So the next article I had here was about this company called Joyent Cloud, and Joyent Cloud did something which a lot of people are upset about, but I thought would be an interesting topic to discuss, which was when they were first beginning, and they actually had a different name previously, they offered people who spent, and I believe it was like on the order of $500 or something, they would get a small hosting account. So this is a website host, but they're slightly different. They're like a infrastructure as a service kind of thing.
Oh, I see.
So, think more kind of like EC2, I guess. Amazon's a kind of equivalent thing. And so they were offering for $500, if you paid them this $500 in about 2006, I think it was, that they would give you a lifetime of hosting, shared hosting plan for a lifetime. And they were a very young company, so giving them a lot of money up front for something that they may go bankrupt in a year or two, that was pretty risky. So people gave them this money, and they used that money to help, fund their startup or whatever. So now turn 2012, 6-7 years later, and they've sent out emails to all of the people who have this account and said, basically, we're ending your account.
Mm-hmm.
We're no longer, this is a legacy account, we're no longer going to provide it. We're going to give you a year free of, our new equivalent plan, and we're going to end your plan. Is that reasonable for them to do? Is that unreasonable?
Yeah, I don't know. It's a tough call, right? Because they took this gamble, and they sort of like they want to have their cake and eat it too, right? Like they took this gamble of getting their initial following by providing this like amazing service, and then now it's sort of like they want to cash in on those people, but also cash in on their support that they gave back when they were new. So it's really, I don't know. I guess, one thing, it must be a large segment of their population, right? Otherwise, they wouldn't have spent the social capital to do this, right?
Okay, interesting. I don't know. It's one of those things where it could be that they're a small percentage, but a large expense. So that the servers are on. So I was reading an article that was related to, I think, United did something similar where they offered for the sum of $300,000 or something. It was like a lot of money. You could buy like lifetime tickets basically, where you go anywhere in the world on, I think it was on United.
Yep, that's right.
Anywhere in the world, anytime you want, and you could buy a companion one for some additional fee. And so people spent like what amounted to like a lot of their savings to buy this, saying that for years when we retire we'll be able to, just
travel
fly wherever
around
we
the
want,
world.
and it. It's like, this is cool. But it turned out United kind of crunched the numbers when they were having some bank problems, that these people who paid, like $300,000 are costing us on average like a couple $1 million a year.
Yeah.
And like taking up seats. And they got all sorts of like priority service. And then there's all these accusations of fraud, like, instead of, a person and their spouse flying, the person would just book a ticket, but book the seat next to them for, under a fake name, just so they wouldn't have to sit next to somebody. And doing things like this. And so there's this like he said, she said between United and the customers, where they're trying to revoke these lifetime tickets because of this abuse. But yet people paid a very large sum of money. And if it turns out United didn't crunch the numbers correctly, whose fault is that?
Yep. Yeah, I mean, it's hard to say, right? One kind of interesting thing that I thought about was I've been reading this book called The Lean Startup. And it's a really interesting book. I haven't read enough of it to like talk about it in any depth or anything, but the chapter I'm on now is what's called the minimum viable product. And the idea is sort of like you cut any corners, you do anything you can to like get something out the door that like people will want. And so this is sort of an example of this, where these guys, they didn't really have a plan of like how their pricing model was going to work or anything like that. So they just did like the bare minimum that they knew everyone would love, got it out the door. But then like and so it like we really worked for them, but then I feel like that's an investment, and so they're sort of like they're defaulting on their investment in these people.
But it's kind of sad that this has become, and some people are even saying like shame on the people who bought this for assuming it actually be kind of a lifetime.
Well,
because I mean, this has happened over and over again, right? Like, you used to have unlimited data, and it turns out, no, it's not actually unlimited.
So it turns out, so I guess people are just not going to trust.
So in general, now you just can't trust when people say unlimited or lifetime or any of this stuff, right? It's just not true, right? Because
we have a bunch of those forever stamps. And I think it's just a matter of time before they're like, well, the forever has come.
Yeah, well, it's interesting because the forever stamps the post office offer says if you buy this and then we increase the cost of a stamp, you can use the forever stamps.
Right.
But it actually, they have some incentive to keep doing it because then they don't have to keep changing print runs for the new amount. So they can print a lot of these forever stamps and just essentially sell them for whatever they want.
Right.
And they don't have to keep printing new stamps with a new number on them.
Right.
So it's somewhat in their advantage to keep doing that, which is a safety as a consumer that they'll want to keep honoring it because
I see
there's
what
like
you're
a
saying.
cost savings for them to keep doing these.
Yeah, that makes sense.
So,
Makes sense.
which is different than a company offering, a completely unlimited or, lifetime style membership.
Yeah, that's fair. Yeah, I mean, realistically, the price of a stamp, let's say it goes up 10 times, right? That's not as bad as these lifetime memberships where it's probably hundreds or thousands of times, value.
Yeah, and so you can say, well, give them back the money they gave. But the thing is, like, well, the people don't want back the money because, like your point, the service is worth more than the money they gave.
Yeah.
Now, in hindsight, it's a really great deal that they made. But at the time, it was risky.
Yeah.
So you need to, like, give them back in proportion to the risk they took. But on the same hand, like, if these people are costing too much money and it would drive the company out of business, what's the, what's the right thing for the business to do?
Yeah, I mean, why should the company have to, like, fold and then reinvent itself just because it made a promise it can't keep?
It's hard to say, but they should because they made a promise, right?
Yeah.
So, like, they should have to keep that. But if the company goes away because this is too expensive, these people are going to lose their plan.
Yeah, it's basically the same thing.
It's the same thing. So it's the same outcome for them. So, yeah, it's just a really hard thing. So just be careful if you're starting a service. Just plan for it to not, plan to go on, right? Don't plan that, we'll go away in a few years. So, this isn't a hard promise to keep.
And in general, I've noticed that I've become really suspicious of temporary anything. So in other words, like cable companies are notorious for this. It's like, I used to have cable TV, and every year I would get like half off my cable bill, and it would last for a year. And at 11 months, I would call the cable company and say I'm canceling. And they're like, oh, we'll extend your special offer. And so it turns out like everybody I worked with, everyone in the office was on the special offer. Like it wasn't really that special, But but just things like that, like scream like scummy and like be careful, you know what I mean? So it's like anytime you see like unlimited or, half off for the next year or whatever, it's always like makes you... For example, I was getting a SSL certificate for Trivapedia, and there was one, it was GoDaddy. They were having like half off for the first year, and it was very hard to find out what it was the second year. And it turns out it was this ridiculous price. Like it was like 3x what I could get somewhere else for the second year. And so just things like that, just be careful for like temporary things or unlimited things because, it's never going to last.
Yeah. So basically you can't trust everything you read on the internet.
Yeah, shocking. So the next news article is on Apple buying a fingerprint company. And yeah, I saw this story actually, and I thought it was kind of interesting. I'm not quite sure does the article say what they plan on doing with it?
Well, of course, it's Apple. No. But
Yeah,
everybody has an
exactly.
opinion.
Yep, yeah.
So there's a company who made fingerprint scanners and had a lot of technology, and they had to make an SEC filing because I believe they're a public company is why, and so
Right.
they have to disclose that Apple is trying to buy them and that they're entering into negotiations, and then somebody has to go and approve it, I guess. And so Apple, they've disclosed that Apple had been trying to make a negotiation to license some technology related to 2D fingerprint scanning, and that now Apple wants to buy them. And so people are speculating that that they're in a hurry, that it seems like everything is very rushed versus normal, so that it might be as early as this year's new iPhone or iPad that it might be coming out, that they might have some sort of fingerprint scanning as a two-factor authentication. Or something like that. So two-factor authentication is something and something you have is a typical two-factor.
Yep, and there's three-factor, right?
I think that adds like something you are, but something you have and something you are seem kind of the same to me, but I might be getting that wrong. All right, so first factor is like username and password. So those are not considered two-factor, although if you want some interesting reads, go read about Microsoft. Not that I want to rag on Microsoft, but they had an interesting post about whether or not they were going to add two-factor authentication to their new Outlook.com, and they consider username and password two factors. But the reason that's not two factors is because that's two things you know. So it's the same. So if somebody figured them out via the same means,
right,
they could hack you, right?
Yep. So that's so just to recap. So a username, a password, something that's sort of in your head that you can just blurt out onto a machine or device. That's one factor.
Yeah. So those are the same factor,
right,
username and password, because they're both something that's in your head.
Right.
But they're also something that if an attacker was able to hack a database, they would have both of those.
Right.
So versus when you add two-factor, typically that next factor is something you have. So this is like World of Warcraft has RSA keys, which are little pieces of plastic.
Wait, World of Warcraft?
Yeah, I think you could for like certain World of Warcraft people,
really?
they get, yeah, I'm pretty sure.
Oh, that's
or
interesting.
other online, or banks do this, or
yeah.
many companies do this for their
cool.
VPNs.
Yeah.
So it basically amounts to a physical device that you have, a little piece of plastic that has a number on it, and that number changes every so often.
Right.
And so the interesting thing about that is you have to type it in. But even if somebody managed to steal the number that you typed in, it was only good for 10 seconds, 30 seconds, a minute, 5 minutes, whatever, however frequently that number changes. And once it changes, they no longer have access to your account because they don't have that object.
Right.
So
and even if they have like a sequence of numbers, a lot of these number generators are like algorithmically designed where you need thousands or millions of numbers in sequence to guess the next one.
Ideally, nobody would be able to guess it if they knew one number, then the next number, then the next. They shouldn't be able to figure it out.
Right.
But yet, it's not random. It's not like a random number generator, although it looks like it. It's not because the person on the server needs to be able to also know what the number is supposed to be.
Right.
So that's typical, like the two-factor thing.
Yep.
Well, but something you have could also be your fingerprint.
So, interestingly, this article, so I'm going to pretend like I know. The reality is I'm totally cheating for those of you at home and reading Wikipedia. But the third factor is something you are. And so a fingerprint or something which like is actually physically part like of you that cannot be like you could give
voice,
you could give the RSA key to somebody else, but you can't give them your finger. So, I think that's the analogy.
So it could be two-factor, could be like password and fingerprint.
Right.
Or three-factor would be password, fingerprint, and RSA key.
RSA. Yep.
Or OTP, one-time password. There's various names for these things.
Mm-hmm.
And so, it's interesting that the iPhone might have this, or maybe that's how you log into a device. Like you have to hold your finger down, and it's a secure thing. And people have lots of issues with fingerprints because fingerprints are pretty easy. They're not considered as safe as some people think they are. If you get someone's fingerprint, now it's hard because you have to know the person. But like if you touch a mug, and then I get that mug, I can actually lift your fingerprint off the mug and then put it on. Like it's pretty easy for me to fool most fingerprint scanners. But in reality, that's still far more secure than an iPhone, which just normally isn't even locked, so your data is not protected at all.
Yep.
And
I mean a password like. I think they have password crackers and things like that.
Yeah, or somebody can just sit there and guess them, or look at the smudges on your screen, or most people don't. There's like all sorts of.
We have like an expert phone cracker here in the audience. That's genius, though. But you're totally right. Like, let's say you had someone's phone and you're some kind of digital forensics expert. You needed to get in. You could probably measure the amount of wear on the different parts of the phone, and that would give you some guess as to...
Yeah, and like a super... But I mean, even just looking at the smudge pattern, or, I mean, most people things are going to be birthdays, anniversary years.
Yeah.
So if you really know the person, you're going to guess, or I bet a lot of them are 000, 1234, 9999, right? I mean, just try the first 20 things, and you're probably going to hack 50, 60, 75% of phones out there. But a fingerprint is nice because, it should be easy to do. You just set it on if it works really well, right? And this is great. So, interesting. Nobody knows, right? It's Apple. It's secretive. They don't say anything. But that would be very curious to see if it comes to their mobile devices or whether it's something more mundane like being on the laptop, which other companies have done before.
Yeah, I know that like one thing that Apple seems to boast in their smartphone, like propaganda or like commercials or whatever, is that is how fast it unlocks. Like that seems to be like a feature. Like it always says like, oh, you can, be like from phone in your pocket to using your phone like faster than any other phone. That's like one of their like key features. And so like adding a fingerprint where you don't have to type in a code. No, actually that's going to make it go faster. Yeah. Because I mean, it's much faster to just put your thumb on something than to punch in.
But it has digits. So my thing is another thing Apple prides itself is it should work and be simple, right?
Yeah.
And fast, right? I mean, this is the kind of thing. But fingerprint scanners, I don't know if you've ever used them, but all the ones I use tend to just be terrible.
So they had one at my university to get into the gym. They used fingerprint scanners, and actually worked really well. I mean, but I will say that I've seen other people have so basically either it works or it doesn't. Like it seems like
so
if you're one of
it
the,
works really well for you.
Yeah, if you're one of the 8% or 3% or whatever, because I've seen people just sit there at the fingerprint scanner and it just doesn't work.
Yeah, well. I mean, so like if you're the FBI, you probably do some image detection on a fingerprint and you have to match 15 distinctive features on the fingerprint or whatever. But I mean, for some of these fingerprint scanners, maybe they only have to detect 2 or 3 features. And then that's enough to, just a random person having the same fingerprint match on 2 or 3 points of view is probably fairly low.
Right.
It's not unique as we think of fingerprints, but it's a 1 in 100,000 chance that just picking up a random person's phone, you're going to have a close enough match to get that.
Yeah,
so you can increase reliability that way.
Yep. I mean, you think about it. If somebody takes your phone, chances are that phone's going to go through maybe 10 people's hands. Like someone will steal your phone. That person might try to get in, might not. Who knows? If they can't get in, they'll probably try to sell your phone on eBay or something. So your phone will go to a third person, but it's not going to cross more than like 50 people.
Yeah.
So if the scanner can be good enough to where the 51st person happens to have a close enough fingerprint, that's okay.
Yeah. So it's all a statistics game of reliability. Yeah. This is a common thing, right? False positive versus false negative.
Yeah.
So the person whose phone it is wants to get in every single time, but everybody else in the world should not be able to get in.
Yeah, exactly.
This is a hard thing to balance.
Yeah, totally. That's a good article.
Talking about companies that change what they're doing in life. Twitter has been in the news a lot.
Yep.
So Twitter made a lot of waves when they went from kind of being focused on the web to start. I think the first thing was they made their own client, and people got a little worried. But then they started buying some big clients. I might get the history exactly wrong.
No, I think you're right.
But now they're making even bigger waves where they're telling third-party clients. So if you are trying to make a website or a piece of software that connects to Twitter and displays tweets on your own, but you're not Twitter, you're going to be limited to 100,000, did it say? 100,000 users.
Yeah.
So no more than 100,000 people can use your service. That's kind of weird. Like, why would you...
That's such an arbitrary number, right?
Well, but even the number, like, that's weird that, like, we're limiting, you cannot become popular. That's basically what they're saying.
Yeah, that's right.
Like, no matter how great you are, you cannot become popular. Not any other, like, it seems like a lot of other ways to limit it. I don't know, but that just seems weird. And I guess for existing, they're doubling it, so, like, you can have 200,000. So this is kind of weird. I know there's, like, limits on how many, or there sometimes are limits on, like, if you're a third-party client, per username you can only make so many requests, right? To help try to prevent, like, denial of service attacks, these kinds of things.
Maybe they're worried if people, like, maybe they've had people just scrape the entire Twitter corpus.
But, I mean, it used to be one of the things where they would provide that to people.
Yeah.
Like, provide the stream, right? And
maybe
that was interesting because people did all this analysis about, what all the tweets were about and sentiment analysis, trying to see if people were happy or sad.
Did you see that?
Olympics
did you read that article on this guy could, within like 100 meters, figure out where you lived based on like your tweets and your friends' tweets, etc.
But that's not surprising.
Yeah. So you think about it, it's like what it did was it sort of like searched you and your friend network, etc., and tried to find like one or two people that had a good bearing on. Like somebody says, for example, I just went to the San Francisco Giants game, right? So it knows that person's in San Fran. And then it like kind of used this like inference diffusion algorithm. But like within 100 meters.
100 meters is really
insane.
good. But the other thing is some people have location data attached. So that makes it even stronger.
Oh, that's true. Yeah.
So some people will have location data. Some people will mention things that are like definite, unique locations. And then even once you have that, you can kind of start like, I went to McDonald's. Well, you probably went to McDonald's close to where all these other things are. Now I can start to get even better and closer.
Yeah.
So
that's amazing.
That is crazy. So Twitter is very valuable, but now they're making it's kind of an interesting thing. They have all these third-party, and that's how they got big. Again, they use these third-party clients. People weren't going to Twitter.com a lot. They were using all these other Twitter clients, and now they're basically getting rid of those. And people say, well, why? And I mean, the one thing we discussed when we brought up this article before we started recording, which I think is interesting, is that these people are accessing Twitter through an API. So Twitter's value is in these 140 character tweets that you're following or whatever. But that means if all they're saying is like, I issue Twitter server a request to say, give me Jason's tweets and his friend's tweets, right? It sends me back these 140 character text. That's the response I expect. But how do you advertise through that? Well, you can inject fake stuff, like here's a sponsored tweet, but that's pretty easy to either just filter out, right? Because that's not in the person's list of friends, or just show, but it's not a big deal. But I can't give you like an image to show, like, hey, you need to show this ad as well.
What would be interesting is if you had to create a session. So in other words, like you asked Twitter, you said, hey, I want to open up a new session, like in your API, and then that session gave you, let's say, like 100 tweets an hour, let's say. I don't know, I'm making that number up. But it gave you X tweets an hour. But then if you wanted another tweet in that session, you had to like they gave you an ad that you had to show. I guess there's no way to know that you
actually showed the ad.
Yeah, this
is a complicated thing. The other thing is that they could charge you per access or something, right?
Yeah.
So then that third parties would have to, give that cost on. So either you pay a one-time fee and they hope you don't, you spend more than that, or there's all sorts of weird ways I guess they could try, but they've just decided I guess this is the way they're going to do it.
Yeah, the problem with this is that there's no path forward. Like, let's say you had an app that had hundreds of thousands of Twitter users and was very popular and highly monetizable. I guess you could contact Twitter directly and negotiate with them, but this policy just kills your business.
Well, it just prevents the businesses from ever starting.
Right.
People just won't start a Twitter business now.
Yep.
Right. But this is interesting because I guess other people like Facebook or even like a Google Plus or other places. They start that way, right? Nobody can access their data.
Right.
And then there are no third-party clients. And then slowly they kind of sometimes let out a little bit of an API to do that. Twitter kind of started the other way, like, oh, we're going to make this available for you. And then now they're kind of becoming more like just Facebook or Google+.
Yeah.
But that kind of, I don't know, that kind of ruins it. Like, then it's not different anymore.
Yeah,
it's just another social network.
It's just one where you can't post as much.
Yeah, you just have, you can't post the picture. You have to post a link to the picture.
So yeah. Do you have a Twitter account?
I do have a Twitter account.
So I actually have a Twitter account that, other than getting hacked, I haven't done anything with it. So apparently I've made tons of posts, but none of them intentional. But I just never understood it. Like, and maybe you could explain it to me, but like, it seems like Twitter is just like a subset of what you could do with Facebook. Like, I didn't quite understand the Twitter concept.
So things have changed, right? The environment. But when it originally came out, for me, what the draw was, I could follow. It was asymmetrical, which Facebook wasn't. So
okay.
Facebook was symmetrical.
Right.
If you were my friend, I was your friend. So that means if you're a celebrity, right, and I was your friend, you could see all of my stupid posts that you didn't care about because you're a celebrity.
Gotcha.
And then I could see all of your posts, like all of them. So in Twitter, the difference was, first of all, it was public. So anybody could see any post you had. So there was no expectation of privacy. And then there was this asymmetric part. So you didn't post things there that you didn't want everybody to see. So that was good. And from me, like, being aggravated at Facebook for how they deceive people about privacy, I liked the fact that it was just easy. Everything is visible. It's all public, right? But then there was this asymmetric thing. If you're a celebrity, I could follow you. You could post something and I could see it. But you didn't necessarily have to see everything that I posted. You could have a different set of people that you followed as a celebrity, and you would only see their information.
Now I
get
it.
Right? So it's... And then Google Plus kind of did the best of both worlds in a way, I guess. Mm-hmm. But there's not as many people there, but doesn't seem like anyways. But this best of both worlds. That
I think just about everyone on Google Plus is a Programming Throwdown follower. So we have a few hundred followers.
Yes!
That's about right.
But Google Plus is both, like, right? Like, I can do asymmetric following,
right?
But if it knows that we're both in a circle, like, I can share stuff to this group specifically versus having to make it all public.
Right, exactly. Yeah, makes sense.
So it is, yeah.
I guess I can see it now. Definitely, like, so Twitter is commonly used in, like, NBC, for example, will say, check our Twitter, and it, like, now it makes sense
because it's public. Because then when you post that
to be like,
hashtag Olympic gold, or whatever thing they put at the bottom of the screen during the Olympics, NBC, Olympic gold or whatever. When they do that, they can boast like, oh, we had 100,000 people use our thing, right? And that's measurable for them. If you did that on Facebook, you would have to like friend them, and they wouldn't necessarily have access to like everything that you were posting related to that.
Yeah, that makes sense.
So.
The NBC Olympics would get me on a huge tirade.
Yeah, let's not let's not get
Patrick gave you this, like, he knows how upset I am that, like,
we haven't even talked about it. But I know how upset I was. I know how upset everybody else I knew was.
Yeah.
So let's not even.
We had to proxy through Europe to watch the Olympics. Anyway, so
tool of the bye week.
Anyways, actually, I have an Olympic prediction, but I'll tell it later.
What prediction?
I have an Olympic prediction.
Olympic.
Here, we'll do it real quick.
All right.
Before
cancel
pre-tool of the bye week. So last Olympics, I made a prediction that I was going to be able to watch the Olympics
in 2008.
In 2008, I made a prediction that in 2012 I was going to be able to watch the Olympics, like, either on YouTube or on something like YouTube, all of it. And that came true if you were not an American. if you're in one of the 97 countries or whatever that
You were not in a like first world, like a large developed country. So it seemed like the list
England
was
was on the list.
Was it?
But
that's because everybody's a BBC subscriber already. They already all pay for BBC, whether they like to or not.
Oh,
if you have
right.
I think the way it works, now I'm probably getting this wrong, in the UK, if you have a TV, you have to pay for BBC.
Ah.
So you already have to pay a subscription.
I didn't know that.
Right? It's like included. I don't know if it's like a tax or a license or a fee you pay.
Okay.
So like they don't have cable providers like we do.
So that was my prediction, and that sort of came true.
Okay.
My prediction for the next Olympics is that...
Wait, so I messed it up. Is this the 2014 Olympics or the 2016 Olympics?
Oh, you mean the Winter Olympics?
Rio or winter?
I think I'll say Rio. Give myself an extra 2 years buffer.
Okay.
By then, definitely any followers will have forgotten. So, but maybe you remember. No. So the prediction is that either using peer-to-peer technology or someone like Microsoft or Google like buying the exclusive rights themselves, one of those two things will happen, and you will be able to, for free, watch the Olympics online. That's my prediction.
I would agree with you, except NBC has already bought the rights, I think, through 2018 or 2020. So regardless, they like you would have to pay, and you'd have to either buy NBC, which owns NBC.
That's devastating.
You'd have to buy the company to get the rights, or you would have to pay them to agree to give you the rights. Like you would have to sub-license from them if they're even allowed to sub-license.
That just crushes my spirit. Yeah. Well, that actually, so that eliminates option number 2. We still have peer-to-peer video streaming.
So, I assume you meant legally.
Oh, well.
Well, if you say illegal, you could watch this one for free.
Yeah, okay, but it's not very accessible, right? Like my grandma can't watch it for free. Easily.
Yeah, okay. This is gonna get into
she has to like change her DNS and all this stuff, right? I mean,
yes.
So there will be some peer-to-peer technology which is like unshutdownable. And there's also other websites that had Olympic content, and you'd go to it the next day, like day 2 of the Olympics, and just an FBI logo. And like the FBI just sees that website.
Oh, wow. I didn't know that, but okay.
Yeah.
You must go to different websites than I do.
No, literally, like I just... Yeah. They did this to this other... No, I'm just kidding. So, so...
Okay, interesting prediction.
That's my predictions.
So the biggest problem I had is, we want to use all this social networking, but you had to stay off of every social network. Even if you get over-the-air free NBC channel, like their one channel that only broadcasts some of the things that were only based... So in America, they only broadcast things that they thought Americans would be interested in.
Yeah.
And basically turned it into a reality show about certain athletes as opposed to certain sports or certain... Just whatever. Very strange.
Yeah, like there's virtually no team sports. Like, and I'm pretty sure that's on purpose.
There were, but regardless. So,
I mean, they're in the minority.
So even if you watched the thing, you had to stay offline because they didn't show it until many hours later. So if you went online, you would see who won the swimming event. It would just be everywhere.
Yeah.
And so then when you watched it 16 hours later, like, that was the part that killed me, is I couldn't go on anything or I would accidentally see who won.
Yep.
Right? Even the sports that NBC was showing or I knew was going to show that I might be interested in,
they were ruined by the
end. I went online.
Yep. Yeah, I totally had that happen.
Yeah.
I went online to see what sports they would show, and that was ruined.
Yeah, now Google News will show you who won, right?
Yeah, exactly. All right.
I implied that you used Google. I have no idea. Maybe you're a Bing user.
Yeah. Bing News showed me who won, but fortunately they were wrong. So no, I'm just kidding.
Oh.
So tool of the bye week. So my tool is GNU Cache, or is it GNU or GNU?
Fast.
I never know. Is it GNU or GNU? Like, do you pronounce the G?
I'm not going to pronounce it.
All right, maybe you could look that up.
I'm not going to fall victim.
I think it's GNU Cache, but anyways, it's GNUCASH, GNU Cache, and the idea here is
2 syllables. GNU.
Oh, it is GNU.
That's what Wikipedia's pronunciation key says.
Wow, learn something new every day. So GNU Cache is like many programs. There's GNU Chess, there's GNU Go, there's GNU CC, the C++ compiler, and the GNU Foundation manages a bunch of open source platforms, and GNU Cache is one of these open source programs. And so what you can do is you can go into like your bank or your credit card or other financial institutions that you're a member of, and you can export to any format you want, actually. Like GNU Cache will take like Microsoft Money or Quicken or the QuickBooks, the new Quicken. They'll take any of these formats. So you export your data. It's like for February, you export your credit card, your bank statements, etc. Then you go into GNU Cache and you import these things, and it will do the job of sort of matching up. So in other words, if you used your checking account to pay your credit card, it'll match those two transactions together and like create what's that called? Double logging or something. Anyways,
the accounting thing.
Yeah, when you match the two. Anyways, so GNU Cache will do all that for you, and it'll try to intelligently, and it gets better at this the more you use it, guess at the categorization of your entries. Yeah. So in the beginning, it actually starts knowing nothing. So like for example, you on your credit card you paid for Shell gas, so Shell will show up, and so you put on there gas. But then through like fuzzy string matching, it over time starts to learn. So now it's at the point where it's kind of trained. We've been using it for a few months, and it knows most of our expenses. Like this is video games, this is gas, this is And the other cool thing it does is it shows you like every month, or you can pick a range of months. It'll show you like pie charts and bar charts showing like how you're doing and what your biggest expenses are. And I cry a little every month when I see like $100+ a month going to cell phone bill. Excuse me, but yeah, it's good to sort of be aware of your expenses. And we were talking about this before the show. Neither Patrick nor I have like a set budget, like, our expenses are going to be X dollars a month. But the better thing is to sort of have this adaptive budget. So, if over time you see, my video game expenses keep going up and up, and, I'm getting addicted to like buying things on Steam and not playing them or whatever, as I am guilty. So you could say, I'm going to tone this down. I'm only going to buy one thing on Steam this week. And so it allows you to sort of self-regulate.
Yeah, this is a common like mind hacking thing.
Yep.
Is that if you want to help make something better, if you just make it visible. So it's not exactly visible where your money's going each month. And people tend to have problems spending less than they make.
Yep.
Which is, you should be doing that, spend less than you make. It's important.
Definitely.
And if you make it visible though, right, like you see how much you're spending in various things, you begin to be conscientious about it. So even if you're not trying to make it go down, you will make it go down. That's typically what happens. Just like this, when they put up a speed limit sign that tells you how fast you're going, even though they don't arrest, like that sign doesn't send you a ticket or anything for the most part, just showing you your speed, people automatically slow down. Because they feel bad. And like, other people are seeing me, right? Like I need to go slower. Or efficiency of your car, like depending on how fast you're going or how fast you accelerate, your car's differing levels of efficient. But even if you don't care about miles per gallon, if you put a meter on there that shows mile per gallon, studies show that you will make your miles per gallon go up.
Yep.
Just, it's human, like you want to make it better.
Yeah, I mean, anytime you see a number, you want to make it go either
whatever
up or
direction
down.
it's supposed to go,
I noticed that there's a community center that I play volleyball at where the speed limit signs are all prime numbers. Really? And like in the like actual place where you park, like in the specific place where you're passing all the spots, the speed limit is 7. And then when you're getting ready to like exit on that sort of main atrium, it's 19. And I just thought that like that really caught my attention, and so I thought that was pretty clever.
I wonder, it's probably not prime. It's probably trying to make it something that you have to actually try for. So if you make it like 15 or 20, people kind of confuse the hash marks, right? Like on the car, and it's like making it a weird number. You have to like count the hashes and be like, I need to stick it here.
Yeah, or at least you think about it.
Yeah,
like you don't see a lot of 7s or 19s. Like that's the first time I've ever seen 19. Yeah. So just making it something different. Sort of it gets you out of what do they call that? Like blindness. Like so there's the term called X blindness. So it'd be like in this case speed limit blindness, where you pass by so many speed limit signs every day that you just become blind to them.
Just subconscious.
Yeah. So this time it's like you see a 19 and you're like, whoa, like you immediately start paying attention. Yeah.
So GNU Cache does this. Yeah, it is helpful.
Yeah, GNU Cache keeps you from broke blindness.
Spending blindness.
So what's your tool of the bye week?
My tool of the bye week is 7-Zip. So
Nice.
7-Zip is an open source Windows tool for meeting all your compression and decompression needs.
Yep. And being the guy who like always like pretends to do like 4 tools, but it's really for different OSs. I'll add P7zip, which does this for OS X and Linux.
Oh, okay. Yeah. All right. So 7zip. So I mean, how many times you go on a forum somewhere or see something, and people are like, how do I unzip this, or how do I?
Yeah.
So it's like, so get 7zip. It'll do all your stuff. So people, it used to be like WinRAR or what was, I forget, the WinZip or whatever. It wasn't one of Windows, but now it's just like 7zip. I have it installed, what they call it, shell extension, so you can right-click on an archive and then just say extract to folder, extract. And first of all, 7zip's really fast, so it's nice. And it's, you don't even normally need to bring up the GUI. It has a GUI, but I hardly ever bring it up. And then it just works, right? Like it's nice. Like you don't have to think about it. It's just the tool to get. And it's not like WinRAR used to be. It's like, what is that called? Pesterware or something?
Yeah,
so like
you get that pop-up.
Free, but like you're supposed to pay after a certain amount of time. And if you don't, it pops up. Nagware, okay, and you kind of like, but 7zip's not like that. You just install it. It just works. They have their own compression format.
Yep.
I think like .7z.
Yep, it's LZMA is the type, is the format.
Is the algorithm?
Yeah.
Okay. Yeah, but it works for RAR files, it works for zip files, it works for tar.gz files, that you get from Linux stuff if you ever need something that's that. It just works. I think it even works on ISO files. Like I think an ISO
it'll like open
like you can
them.
unzip the ISO into its component files.
Yep.
Of course, some ISOs can contain stuff like boot sectors and things, so I'm sure it probably just ditches those.
Yeah, probably.
But like all the files that are there, it'll extract. So it's really useful.
Yep. And 7zip is like the best compression you're gonna get without knowing the media. Like if you're not like an MP3 will always beat 7zip because it's lossy and it's made for music.
That's cheating. But
yeah. But if you don't know what you're zipping or you just want a general utility, 7zip will give you the best compression.
Nice.
Out there.
Nice.
So
yeah, I recommend that.
Yeah, it's great. Multi-threaded too, so it runs pretty fast.
Yep.
And it's good stuff. Definitely get that.
Yep. All right, so on to our programming language of the week. I don't even know if we announced it. I guess we did announce at the beginning. We're covering Go.
Yes. Go. Maybe they,
Go Gadget.
If you
Umbrella.
If you didn't know, you might think that I was just telling you to start talking. Like,
Leave.
episode 18, go, and then you just start talking.
Ah.
Yeah, Patrick left the building. So, so Go is Go is actually an imperative language that was invented at Google.
Oh, okay.
But it has sort of a lot of nice, like, sort of functional characteristics that make it
So it's
really
pretty
useful.
new, right?
Yeah, so...
2 years ago now?
Something like that. I mean, Go 1.0 came out, March? So that's, what is it now, August? So yeah, just about 6 months ago, the 1.0, like the official version came out. Before that, they had sort of like these release candidates that...
Okay.
That had varying levels of functionality. Like batteries, like as far from included as possible. Even like, I remember when it first came out a couple of years ago, you needed to download a library just to print to the screen. Like you had to go on the internet and get like another package for printing. And I was like, this is ridiculous.
Yeah.
But now, they have a lot of those things included, like file I/O and printing and all that stuff. Is all totally in there now.
So the thing that I remember when I first started hearing the press releases about Go and people talking about it, as people tend to do anytime Google says anything, was this, it was built for multi-processor environment. Like, now that our computers have many cores and that kind of stuff, and that it was going to be, it's not multi-threaded, I remember it wasn't, but people said that it was built for things that have multiple cores and multiple processors. So what did they use to do that handle concurrency?
Right, so they use Go routines. And Go routines is sort of a play on words. It's a play on coroutines, which I think we've talked about actually on the show.
Okay.
But I'll just recap quickly. So you have, let's just go through the layers. You have processes. And so if you ever go to like your task manager in Windows, or you type top in Linux, or on the Mac, you go to the, activity monitor, you can see a list of your processes. Like I have Chrome, I have Firefox, I have, Adium, Instant Messenger, etc. That's like the highest level of granularity. And so starting up a process is pretty time consuming, and you're not supposed to have thousands of processes running or hundreds of thousands, right? You're supposed to have just
not unless you're infected with malware.
Yeah, that's right. Our parents probably have. Well, maybe not your parents. Your parents are pretty tech savvy, but I'm sure my parents have thousands of processes. But anyways, so you're intended to have 20, 30, as many as you have programs running, right? Then the next level down, a process can create multiple threads. And so threads can sort of allow you to do two things at exactly the same time. And you can have different threads running on different cores of your machine. And so you get, n-way parallelism. So let's say you wanted to, let's say the 7-zip, for example. So 7-zip will take, let's say 7-zip knows you have 4 cores on your computer. Well, they'll take your file, split it into 4 chunks, and do the compression on each chunk on a different thread, on a different core. And so once it's done, all those threads will come back together and merge the chunks. So that's threads. But in many environments, you actually want, so along with processes, you can't have that many threads. Like you can actually only have a few hundred threads total. Some operating systems, some, if you have enough memory and things, you can get to 1,000 or even 2,000. It's extremely rare. If you're making an application for everyday users, you can't really feasibly go over 100 threads safely. So, but you might want to do 1,000 things at the same time, right? Like that might make your program easier to write, easier to understand. Maybe if you're doing like disk kind of stuff, you might only have like 90 of these that need the CPU at one time, but you have the other like 900 waiting on the network, right? So to do that, they invented coroutines. And the idea is coroutines is something that sits on top of a thread pool. So you might have, let's say, your application might have 10 threads that are all just kind of sitting there waiting for work. And you might have 10,000 coroutines. And the coroutine says, hey, I have stuff to do. Give me a thread that's available. And so you have up to, let's say 4 coroutines that can do that. And then once they're like, oh, I'm waiting for the hard drive, this thread can work on another coroutine. So coroutines have been awesome. Stackless Python is one of the first programming languages that had coroutines. Now Ruby has them. But for people who have heard of EVE Online, the MMO, that whole thing runs on a few machines that have stackless Python. And every AI is running its own coroutine. So if you imagine there's like millions of computer opponents in the game, and each one of them has a coroutine that's sort of running at its own pace.
The interesting thing about EVE Online, well, one of the many interesting things about EVE Online
phenomenal.
Is that as opposed to most massively multiplayer online games where there's essentially parallel worlds where if you exist in one world, you only exist in that world, and it's not easy to travel to another world, and all player activity doesn't exist in just one world. But EVE Online, every player logged in, all exist in one common shared world.
Yep. Yeah, exactly. And so one of the reasons why they were able to do that is because they picked a technology that scales so well. So, if it wouldn't be possible to have, a lot of these like World of Warcraft and things like that, they might do like a thread for every zone AI. Like each zone will have like for all the AI running in that zone, one thread. And so if you follow that logic, you can only have a few hundred or 1,000 zones, right? And then you have to, use a new machine. So, Go, understood that coroutines are awesome and that we want to sort of like take advantage of that. But they also understood that a lot of people who need this kind of tech aren't Python and Ruby programmers. They're guys who do like low level, like networking or like this backend for World of Warcraft, like heavy data processing and things like that. So they created a language that was very similar to C or C++, but with this coroutine support.
Looking at Go code, it really does look a lot like C. You can almost just read it like it's C.
Yep. Yeah, it has the option of being strong or weakly typed. You can actually do like X colon equals and then anything. So if you change the return value of the function, now X's type changes. But you can also be explicit and say like,
integer.
Yeah, it's actually backwards. It's really confusing when you see it for the first time. It's like X int equals, which is like really throws you off. But yeah, you can say effectively like X is an integer and it's equal to the output of this function. And then if the function output changes, you'll get a compiler error. So it gives you that safety that you often need when you're doing these like critical backend. Like if you think about it, you can have a front end in JavaScript, as most browser front ends are. And if something crashes, your program will keep running. Like let's say you're using Gmail or Yahoo Mail or something. You go to open a mail and your JavaScript crashes. You'll just try to open another mail and you're okay, or you'll reload the page and the whole JavaScript engine will refresh. If your backend crashes, you're in big trouble. Like if the thing that writes the database crashes, then like everybody's hosed.
That's when the server goes down. That's when you say that the website's down.
Yeah, then everybody on using your service gets the screen with like a team of monkeys has been dispatched to fix the problem.
Or the whale with all the balloons.
Oh, I haven't seen that one.
The fail whale.
That's awesome. What is that on?
Yeah, that's a Twitter one, right?
Oh, all I know is the YouTube one. The team of monkeys has been dispatched. But actually, there's the crying robot too on Gmail. But anyways, so if a Go is an attempt to sort of give you that safety that C++ gives you, the strong type and everything, and even give you more safety because Go has a garbage collection and safe pointers, so you don't have to worry about buffer overruns.
So you can't do arbitrary pointer math.
Yep.
Oh.
Well, actually,
gone are the crazy C operations.
No, you're right. You can't.
It's memory safe.
Yep. It's totally memory safe.
It can be type safe. Yep.
So yeah, you can do crazy, like you can add pointers, but if you ever go out of bounds, you'll get a runtime error. As opposed to like in C where it'll just kind of let you do crazy
depending on
things.
If you do something bad or not.
Yeah. Like if you have some kind of static thing, it'll, like if C, you can allocate a huge array and then have smaller arrays inside of it and do all sorts of funky things with memory. You can't do that with Go. But
they try to still, they try to give you some ability to kind of lay out memory and control more how memory is done so that it still stays efficient because you can have more control over how things are done because you know what it should act like.
Yep.
As opposed to just, kind of, I think the way Java more approaches it is like, doesn't really give you any control over that. Like, look, we know what we're doing. You just write your code and we'll handle everything else.
Yep.
But sometimes you can impart knowledge. Like, hey, I know, like, let me give you this hint. Like, hey, put these things next to each other because I'm going to keep using them over and over again.
Yep. Yeah, totally. Yeah, Go gives you that. Go gives you sort of that flexibility that you can do that, lets you do that, which is awesome. So Go works, as we mentioned, with Go routines, and the way that these routines talk to each other is through channels. And so the idea is, if you've ever used a concurrent queue in Java, you know what a channel is. It's exactly that. So what a concurrent queue is, first let's talk about what a queue is. A queue is I always get this mixed up.
First in, first out.
Yes, that's a queue. I always get those two mixed up for some reason. Like
a queue is like literally like a pipe, like or like a line when you queue up to get your Starbucks or your McDonald's or whatever. Mm-hmm. The first person who gets there is the first person who gets served, and everybody who comes next, if there's somebody in front of them, has to wait behind that person in front of them.
Right, but like in the case of a stack, which is
last in, first out. So
right.
The most recent person to get there is the first person to be served.
See, I found out now why I get it confused. Because I think, let's say you have a bunch of things already in the stack, and you put a thing in the stack. I think sometimes I can think that's the first thing, because it's like the thing you just put in. But that's totally wrong. So just to clear it, the thing you just put onto the structure is the last thing.
Yes.
And so when the first thing goes out,
the most recent timestamp.
Yeah, that's a good way
of the event.
At it. Yeah, that's the last thing. And so so a queue is a first in, first out, and you can use these channels, which are queues, to talk between amongst Go routines. And the interesting thing is it can be blocking. It doesn't have to be, but it can be. So for example, you could create 10 Go. Let's say you're implementing 7-zip, for example. You could create 10 Go routines that would compute 10. That would compress 10 chunks of memory, one each, and then would pass the compressed chunks through one of these channels. Then in your main program, you would say, Go and then the first function, Go space second function, Go space third. And then at the end of the 10 functions, or in a for loop, at the end of that, you could have another for loop from 1 to 10 where you just read from the channel.
And you block. So even if channel 5 finishes before channel 1, you won't look at it because you're waiting for channel 1.
Oh, so you can actually do both.
Okay.
You can actually block in order to where like the first Go routine has to answer first. Or you can just block and say once any of these 10 finishes, then do something with the data and then wait.
So in the case of 7-zip, you'd be interested in having it ordered because you need to write it out ordered to the file typically.
Right.
But in other something, you may not care.
Right, exactly.
The first thing that gets done, let me know because I want to start doing work again.
Yep. And so there's some things that make this really great. So we'll talk about some of the strengths. One strength is that to turn something from a function call, which is synchronous. So let's say you laid out your program as if you had written it in C, and it just said for I equals 0 to 10, compress chunk I, and then for I equals 0 to 10, write chunk I. You could write that in C, and it would just use one thread and one routine, and it would just execute in parallel or in sequence. And if you had any bugs, you would find them and things like that. If you wrote it in Go, or if you wanted to change it into using more than one core, all you have to do is put the word Go in front of the function. Well, and you have to do the channel stuff, right? But the idea here is the channels will work and the functions will work without Go. So if you don't put the word Go, it'll only use one core and everything will run in sequence, which is great for debugging. And your channels will, obviously your channel will completely fill up before you get to that stage where it empties because it'll do all 10 in blocking, right? But it's cool because you can test it and you can see if there are any bugs and things like that. Then all you do is you go in your code and you add go, and as long as you've done it right, all of a sudden now your program's using all the cores on your machine and it running super fast. But most of the time when you get to that stage, it's already well tested, and so that whole pipeline of development I found to be really nice.
Yeah, that is nice.
Yeah. And the other thing is, because they're coroutines and not threads, you don't have to worry about using too many of them. So let's say you broke your file up into 1 meg chunks, and each chunk you tried to process in parallel. Well, if you use threads and I gave you a 10 gigabyte file and you tried to create 10,000 threads, you'd crash the OS and it'd be a nightmare, right? But in Go, you can create 10,000 Go routines and they know the 9,998 of them would know you only have 2 cores, not to, waste your time. And so they just sit there.
So you talked about, maybe skipping ahead a little bit, you're just kind of getting to the strengths. So this, I even brought it up, this concurrency is kind of baked in. It's pretty nice. People seem to like it. It's lightweight, it's not a big chore to get it set up and working it can be in some languages. And then you don't really have to worry about all this thread, and I need to start up a thread pool, and then I need to have a queue, and threads need to service the queue, and all that kind of stuff is just taken care of, which is really nice because now that processors aren't really getting any faster, but we're getting more of them. Even phones now are going to have, I think, 4 processors in them.
Yep. And now they have those 64 core desktop processors. It's just insane. Yeah.
So those are strengths, but with strengths come weaknesses.
Yeah, that's right.
So one of the weaknesses is this no generics. So it's hard to write something that operates. Generics is what the Java name is, and or in C++ it's called templates.
Yep.
So this is you write one function and it kind of knows how to operate on all sorts of different types that are passed in.
Yep.
And then the other thing is it's still pretty new. And as with anything, if you're going to try to use this at work, I'm not going to vouch for, Google might vouch for it, but I'm not going to vouch for how reliable this is or how great it is or that it'll work. So if you're trying to go to your boss and hey, I want to write our entire startup company, we want to make it based on Go.
Yeah.
That might be, you might be a genius 5 years from now, or you might ruin your startup and have to rewrite when they have to rewrite all their code, just because it doesn't have that track record, that history. But it is good for using, we always encourage people to find that little project or that little tool that you need to write and implement it in Go. And then one day it will have that track record, or it'll pass by the wayside. But
one of the two.
Everything starts at some point, right? C++ used to be brand new, and people laughed at it and said nobody will ever use that. And now it's what did we do before C++? Or and Java's becoming that same way. And, so so Go. Maybe one day people will look back and be like, back when I was a kid, Go was a young whippersnapper.
Yeah, exactly. But it's interesting that you mentioned C++ because just think how hard this stuff is. So remember, the people that Go language is going after, in my opinion, are the C, C++, the really low level. And to do this kind of stuff in C++ is super hard, right? I mean, even just threading. Like, I don't know about you, but anytime I've had to do multi-threading, I've had to use Boost Thread, because like Boost Thread has all this code which like wraps around this. Like it'll say, oh, I'm in Windows, I need to use what is it called? The threading library in Windows, not WinSock. But anyways, uses something. If you're in Linux, it uses pthread, or Mac uses pthread. So then if you want to do thread pools, you have to write the thread pool code yourself and handle that, and like make sure all the threads are like busy, and like you have to do all that yourself. It's just insane. And so Go gives you all of that for free, and still gives you a lot of the constructs in C and C++ that low-level programmers really like.
Yeah, I guess my point is like I was saying, it's a track record thing, right?
Yeah, so totally.
Don't be surprised if your boss isn't gung-ho about it.
Yeah, exactly.
Like, or, if you're in university, writing a research paper in Go, it might be great, and there might be a lot of stuff to study, but the problem is, in 10 years from now, if your plan is to have that research paper be worth something in 10 years, you'd rather build on something that has people kind of, it's trusted, it's well known,
and it's going to be there, around, and the compiler will exist for future machines.
Right, like C++, like, I mean, even if people stop writing code in it, there's just so much code that is written in it.
Yep.
Support somewhere by somebody, it seems like it would just have to continue, right?
Yeah, and I mean, that's why like C++ is so ubiquitous that the Android has the native development kit, and I think iPhone has something. Actually, iPhone C++ just works natively. Mm-hmm. So yeah, I mean, like, these languages have stood the test of time long enough to where you could write something in C++ and someone could use it on Android, right? I mean, right now that's not true with Go, and it might never be true. So
I mean, it doesn't have its place; it's just not ready yet.
Yeah, and there's also, along those lines, there's not a lot of bindings for Go. So in other words, let's say you wanted to use 7-zip, for example. Let's say you wanted to use 7-zip inside your program, and you were writing. So 7-zip.
Well, 7-zip source code. Part or library.
Yeah, right.
Of their program. Yeah.
So 7-zip is written in C++, but if you wanted to use it in Java, there's a binding for it, which means that the 7-zip people, or maybe somebody else, some hobbyist, has gone in and written the glue code to access 7-zip.
In Java.
C++ libraries from Java, and so Java has a ton of these bindings to other libraries, but Go doesn't have any of this yet.
Yep.
So
as far as tools go, there's 2 different compilers for Go. So many.
Yeah, I mean this. I think this is common, right? Because C++ was the same way. There was a number of different compilers, and then remember when there was. It's like Turbo C++.
Well, there are many. I mean, you got like the Microsoft compilers. You've got GCC. I mean, there are typically multiple compilers, and it's interesting that though one person, essentially Google, is developing Go, and they've still thought to release 2 compilers.
Yeah. So, so in this case, but actually the 2 compilers have different sort of use cases, I guess you could say, or different sort of applications. The regular Go compiler has a really fast compile time, but it has really slow. It has not really slow, but it's a slower runtime. And so there's also a version called GCC Go, and what this does is it runs like a Go preprocessor on the code. And so for people who don't know, GCC is more than just a C compiler. It also does C++, obviously the G++, but there's GCJ for Java. There's everything.
It basically exists for like every programming language.
I'm trying to think. I can't come up with another one, but I know there is at least one more.
Almost every language.
There's GCD for decompiling. So anyways, so all of them compile down to this intermediary code, which I don't know, it has some name. And
so there's the front end. So you can have a different front end that, like you're saying, like a precompiler that produces this output file of a certain format.
Right.
That represents kind of the programming structure as opposed to the specific language.
Right, exactly. And then there's the GCC backend, which can take things from GCJ, GCC, G++. It can take output from all of these because they're all in the same format. and just do a ton of like optimizations.
Crazy like research-based optimization.
Yeah, like this for loop could be unfurled or unrolled. This one can't, and there's some crazy branching we can do here to try both branches, etc. So GCC Go has a Go front end with the GCC back end, and because it's doing all this crazy funky stuff, it takes longer to compile, but then it should in theory run faster. So
you can, when you're doing the interactive, like try something, run it, you can do the fast compile times. You don't waste a lot of your time.
Yep.
But then when you're ready to kind of like, start testing performance or tuning that, then you can switch over to the GCC Go.
Yeah, totally.
It's nice.
Another cool tool is this is more of I guess a doc than a tool, but it's organizing Go code. I found this really useful. I've been writing Go for the past like few weeks, and I found this kind of useful in sort of laying out, understanding, what is a package and what's a package supposed to contain. Because in languages like C++ and Go, the package, and even in Java actually, like I never quite understood like I have 20 files. Should I try to group these files into different packages? Like, what's the limit?
Yeah.
And so it tries to address some of those, like, I guess, like philosophical or maybe architectural questions. So, those are some pretty good tools to get people started.
Yeah, I think we've got some. Go. It's new, but it's cool. It's good for a lot of like low level systems programming, like we're talking about, like applications, backend stuff. Watch where it goes.
Yeah, I mean, think about if you write a server in Go. Typically the way a server works is you have some kind of thread pool, and then people access your server. Like somebody hits your website, and it looks for an open thread to service like that web request, right? So pretty much everything you do on the web that's server side, or anything you do that has to service a lot of customers, relies on some kind of thread pool. And as we mentioned, in C++ there is no thread pool. You have to write that yourself. So this stuff in Go becomes very easy. Like if somebody hits your website and it has a Go backend, you just kick off a Go routine. And you don't worry about, if 1 million people hit my website at the same time, I'll kill the operating system.
Might go really slow.
Yeah, I mean, that millionth person that hit the website, they might not get service. The request, like their browser might tell them that this website is not available. And you can actually, before kicking off the Go routine, you could check and things like that. But the important thing is that you're doing something really low level, but you don't run the risk of blowing up the operating system, right? I mean, that's sort of the nice thing about it.
Yep.
Yeah.
Yep. We've gotten some awesome feedback about our Java episode. People like that. People had some comments, and we read them all. We don't always reply, or at least not expediently, to all of our stuff. We do read them. We are listening. We're paying attention to some new languages people have written and asked for. The queue is growing. It's not first in, first out. I guess maybe it's a priority queue.
That's right.
But the languages are growing faster than we're actually recording them. So,
yeah, we definitely are going to spend the next few episodes getting back to some of those requests. So
yep. But thanks for all the feedback. As always, you can find us on our Google Plus page or email us at programmingthrowdown@gmail.com.
Yeah, if you write any cool programs in Go, definitely post us a link or something. Tell us about them.
All right. Well, till next time.
See you guys later. The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.